watch off and subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about your physics class 11, and that is your class 44, which is we had to do here. In 44th class, before that we had done your 43rd classes of the session, and that we had done your friction, which is related to the relative motion as well. We had done your numerical in the last classes of related to the friction. Now we'll continue with the numerical and then we'll go for the ruling friction. But before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and every day you can also enjoy the video as well. So let's go for it. That the question which is your ninth question of this unit, but the first question of this session as well. So let's go for it. The ninth question we have: what is the acceleration of the block and the trolley system shown in the figure if the coefficient of kinetic friction between the trolley and the surface is 0.04? What is the tension in the spring? Take G equals to 10 meter second inverse square. Neglect the mass of the string. That is the question here. So let's go for the solution. And as I had given you this question as a homework, so if you had done, you can just tell me on the comment section done with the answer, and if you had not done, you can just copy it down from here. Let's go for it. Question is, what is the acceleration of the block and trolley system as shown in the figure? If the coefficient of kinetic friction between the trolley and the surface is 0.04, what is the tension in the string? Take G equals to 10. Neglect the mass of the string. Let's go for the solution. So, but before that we have a figure here, so just I will label it out with A, B and C so that you will get to know about in the detail. So the figure, it is being this is FK, weight 20 kg, and this is the tension. kg. Weight 30 Newton. This is a figure A. Okay. Figure B is D. This is your 30 Newton. This is figure B. Now figure C is D. This is W weight. This is FK. Okay, so this is your figure C. Now we go for the solution. We'll find out. We go for the solution here, and that is of course being important one. So with this you have to solve one by one, as I told you. In the same way here, as the string is inextensible and pulley is smooth, so the 3 kg block and the 20 kg trolley both have same magnitude of the acceleration, that is applying second law to the motion of the block. So applying the second law to motion of the trolley, motion of the block, motion of the block. So that is 30 minus t equals to 3. Applying second law motion of the trolley, अलग से apply the second law to motion of the trolley, that is t minus fk equals to 28. Now fk equals to mu k and mu k equals to 0.04, n equals to 20 into 10 equals to 200 Newton. Thus the equation of the motion of the trolley, thus the equation for the motion of the trolley is t minus 0.04 into 200 equals to 20a, or t minus 8 equals to 20a. These equations give a equals to 22 by 23 meter second inverse square, 0.96 meter second inverse square, and t equals to 37.1 Newton. Now we discuss about the rolling friction. That is of course being important one. So we will go for it, and let's go for the same. Rolling friction. In terms of rolling friction, a body like a ring or a sphere rolling without slipping over an horizontal plane will suffer no friction in principle, and in principle at every instant there just at a point of contact between the body and the plane, and that point has no motion relative to plane, and in this ideal situation kinetic or static friction that is zero, and the body should continue to roll with constant velocity, and we know in practice this will not happen, and some resistance to motion, that is rolling friction, does occur. that is to keep the body rolling, and some applied force is needed, and for the same weight rolling friction is much smaller, even by 2 or 3 order of magnitude, than static or sliding friction. This is the reason why discovery of the wheel has been a major milestone in human history. And the rolling friction, again a complex origin, though somewhat different from that of static and sliding friction, and during the rolling the surfaces in contact get momentarily deformed a little, and this result is the finite area, not a point of the body being in contact with the surface, and that the net effect is that of the component of the contact force that parallel to the surface of opposes the motion. We often regard the friction as something undesirable, and in many situations, like in machine with different moving parts, friction does have negative role. It opposes relative motion and thereby disappears power in the form of heat, etc. Lubricants are a way of reducing kinetic friction in a machine, and another way is to use ball bearing between the two moving parts of a machine, where since the rolling friction between ball bearing and the surface in contact is very high, power dissipation is reduced and a thin cushion of air maintained between solid surface in relative motion, in another effective way of reducing the friction here. In many practical situations, however, the friction is critically needed, and kinetic friction that disappears power is nevertheless important for a quickly stopping relative motion. It is made use of by brakes in machines and automobiles. Similarly, static friction is important in daily life. We are able to walk because of friction, and it is impossible for a car to move on a very slippery road, on an ordinary road, or the friction between the tires and the road provides the necessary external force to accelerate the car as well. On the same way, we will go for that the tires. We have some ways of reducing the friction. We are ball pairing the place between moving part of the machine that is being used as for the compression, and that compression fusion of air between the surfaces and the relative motion that we have, the plastic disc hole, air fusion and inflated balloon. So that is what we have in between, and which will emphasize your rolling friction while you are rolling a ball, that is in between, where the air has also been that has been inserted in it. Now we go for another one, and that is what we have to discuss is the circular motion. In terms of circular motion, there is a motion of a car on a level road that we have, and a motion of a car on a banked road as well. So that is what we all discussed here in the last class, which is in 45th class. In the next coming class, we will discuss in the detail, because that has been coming from very detailed about it. So we'll discuss solving problems in mechanics, that is comes under in it, and with the help of that we have to do your reaction pairs as well. Hopefully in the next coming class we'll be going to end up with this particular unit. So I will just conclude some of the points related to it here, and so that it will be get to know that what we have to discuss here, where in the same way, point that you have to the ponder, that you can remember that force is not always a direction of motion, and that depending on the situation, force may be along with opposite to V and that normal to V, and of course may some other angle over V, in the case it is parallel to the acceleration. If V equals to 0 at an instant, that is if the body is a momentary at best, and it does not mean that force or accelerations are necessary 0 at that instant. For example, when a ball thrown upward reaches its maximum height, and your V equals to 0, but the force continues to be its weight mg, and the acceleration is not 0 but g. And on the same way, the force on a body at a given time is determined by the situation at the location of the body at that time, and force is not carried by the body from its earlier history of motion, and that the motion after a stone is released out as an accelerated train. There is no horizontal force for or acceleration on the stone, and if the effect of that, the surrounding are neglected, the stone that has only the vertical forces of gravity. In the second law of motion, where force equals to ma, which is mass into acceleration, where F stands for the net force due to the material agency eternal to the body, and A is the effect of the force, and ma that should be here. Where in the same way, the centripetal force that should not be regarded as yet another kind of force, and it is simply a name given to the force that provides towards radial acceleration to the body in circular motion. We should always look for some material force like tension, gravitational force, electrical force, friction, etc. as the centripetal force in any circular motion. Static friction is a self-adjusting force up to its limit, which is do not put Fk equals to, that is mu p and without being sure that the maximum value of static friction is coming into play. Other than that, where the family equation mg is equals to r for a body on a table is true only if the body is in the equilibrium, and that the two forces mg and r that can be a different example. Your body is in accelerated lift, and that equality of mg and r that has no connection with the third law. The term here, the term action and the reaction is the third law of motion. Simply that stands for the simultaneously mutual forces between a pair of bodies, and unlike their meaning in ordinary language, action does not precede or cause a reaction, and action and reaction act on different bodies. With the different terms like friction, normal reaction, tension, air resistance, viscous drag, thrust, buoyancy, weight, centripetal force, all stands for as force in a different context. And for clarity, every force n is equivalent to the terms encountered in the mechanics that should be reduced to the phase force on A by B. Where for applying the second law, that is of motion, there is no conceptual distinctions between inanimate and animate objects, and animate objects that such as human also requires an external force to accelerate, and for example, without the external force or friction we cannot walk on the ground. The objective concepts of force in physics that should not be confused with the subjective concepts of feeling of forces. And on a merry-go-round around, that is all parts of our body are subject to an onward force, and but we have a feeling of being pushed outward the direction of impending the motions as well. Now we go for the detail about it here, and that is that we discuss what you have to remember about regarding the points. Now we go for some of the questions related to it, so that it will be helpful for you to go for it, and that we will discuss in the next coming class, because it will be extended more than the limit of time that you are watching. So now we're gonna end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.